acid bases. All right. So now just the few things that I need you to have in your mind. Some theories about acids and bases, right? So what we have learned up till now is we have been able to learn generally we described acids as the substances that are going to give H positive ion, right? And for bases, we were able to see that some substances that give OH negative ion in an aqueous solution, right? There are some theories that should be there in your mind according to the specification. Uh, Acids are proton donors. Acid is a proton donor. Acids are proton donor. What does proton over here mean? It means an H positive ion,
Mm-hmm.
right? This is what we have already understood, right? If you look at an ionic equation, we saw that they give H positive ion, right? Proton donors. Bases are basically proton acceptors. They are considered as the one who accept protons. Where is that coming from? It is coming from that bases already have this OH negative ion alkalis, or when they dissolve in water, and when they accept H positive ion to give you H2O, which is the neutralization reaction. You understand? Similarly, it goes with the same for the acids as well. They give H positive ion. They are proton donors, and the others are proton acceptors, right? How, and this is called a Bronsted-Lowry theory. It's called a Bronsted-Lowry theory. I'll write few examples for this as well. Look at it. Let's take hydrogen chloride and water. What do you generally get? This is what actually takes place. H3O plus Cl negative. H3O plus Cl negative. This is called hydroxium ion. Hydro hydroxonium ion. Hydroxonium ion, it has a positive charge in it as well. You understand this?
Mm-hmm.
H3O. So water here is acting as a base here. It is acting as a base. As HCl is acting as an acid. You get it? Acting as base, acting as an acid, acting as base. You understand? Why? Because according to the Bronsted-Lowry theory, acids are all those substances that actually give H positive ion, and bases are all those substances that actually accept H positive ion. One of the examples is this. Do you get it?
Yeah.
Similarly, we can also have this. NH3 is a known base. We are all aware of that. NH3, ammonia, reacts with HCl. Then it reacts with HCl. This is what we actually get. NH4 positive plus Cl negative. So Cl negative has become an acid and ammonia has become a base. Why? Because it has accepted, a proton. And why do we call this H positive ion a proton? If you look at H is 1 1, right? So it means what? It means it has one electron, one proton, and zero neutrons. Making sense or no? How do we
Yeah.
calculate? This is the atomic mass, nucleon number, nucleon number, right? So what was that? Nucleon number minus proton gives you number of neutrons. You get it? So it's zero. So when what happens when it is going to? So this is how H positive ion looks like. H positive ion. This is what H positive actually looks like, right? There's one proton in it, and then there is one electron outside. So if one proton is lost, what are you left with? When proton, right? You're only left with one proton. That is why we called H positive ion as proton. You understand?
Yeah.
So let's write this down. Similarly, another reaction that we can just write over here, just to clarify things more and better. If you look at this reaction, this is generally it generally looks like this. This is the result that we generally get. You see, so how water has acted as an acid. Acts as an acid, and this ammonia acts as a base. Why? Because it base acts as base because it has accepted an H positive ion here. You get it?
Yeah.